Hello guys, so I'll be just walking you through the process of just setting this asset up. If you have purchased the asset, thank you so much, you helped me a lot. So basically there is nothing too much, like I have already put everything outside and the asset is totally dynamic. So I'll just show you through all the steps so that you can recreate what I've created. So first, with this procedural mesh, so you can set the location of this mesh anywhere, and this default tag you see, npc tag name, this will be the tag you put in your npc character blueprint, and you can just copy the tag and paste it here, and the npc will be able to react to this water as well as your character. Then second is this collision y extent. This is the collision extent on the y-axis. You can see this here. This is the y-axis of the collision, and this can be set up as well. Then these all are the for the distortion of the vertices. This is the Hooke's law, and this will be the number of iterations. This will be how many times the loop will run and find the information, like the disturbance of vertices and everything. So you keep in mind that the number of iterations are not you don't go crazy about this number of iterations, because each iteration will be run number of vertices times, so this can add up a lot. Although I have made this asset keeping optimization in mind, and I'm also using custom tick functions instead of tick. So but you keep in mind that number of iterations you keep at the low end. For this scale of water, I'll just keep the iteration to 8. Let's see how this works. Then these 3 values are the most important in the flow of this water. The water will react. This is basically Hooke's law, and so Hooke's law is for the springs. So each vertice in this water is a spring, and these values will determine how far and how long the water will oscillate. So first, stiffness will determine whether this each vertice of the water is just how stiff is this vertice. Like if it is this value is set to a really low end, so you keep in mind this stiffness value. This stiffness value is really important. If you keep the stiffness value to the high end, then the vertice will keep oscillating at the point, and it will go like, if the dampening is less and the stiffness is more, the vertice will go out of control. So you keep this in mind that the stiffness value is really low. Dampening will just is just a reverse force, like how fast this water will settle. So that is dampening. And the spread is how far the water will spread, like how far the force will be applied after one vertice is disturbed, like 3 vertices after that or something like that. So this spread is there. You can easily customize this. Just keep this in mind that the stiffness value and the dampening value, they should be like in this ratio. And these are carefully selected, so they will work out of the box, but depending on the scale of your water, you might need to alterate some. Then this is the idle situation. That is when the water is at the idle situation, like there is no overlapping, and character is not overlapping, the floatable object is not overlapping. So at that point, the water will start flowing, start disturbing on its own. It will just randomly pull some vertices and it will imitate flowing of water. So that is for that. All right, and the next is okay Niagara system. Yes, so if you have a Niagara particle system, this water is inbuilt some things, like you can just click on this particle spawn system, and after that you can apply this npc template or something like that. the order is reversed. All right, so for the npc system you can just click on this and apply this npc particle system, whatever your particle system you can apply here, and the npc will release the particles like when it is entering the water. At that point, at this point, it will release the particles, and when it is jumping again, when it is jumping at that point, it will release the particles, not while walking and anything. So it is set up for that. You can directly use it. Then next is procedural mesh. Okay, for this you can just set this number of columns. Will be how many number of columns you want, like what will be the length. You can just set it to 100 also. It doesn't matter, since it is procedural, it will be really quick. You see, it goes beyond there. It's really quick. And for this example, I think 21 or 17 will do. Yep, 17 or 16 will do. It's just fine. 17 will do. So this is it. For the column height, this will be the height of the water. For this example, we'll just put 255. Column width will be each column, what is the width of each column. This will also vary depending on the length of your water or how smooth you want your water to be. So each of these values are easily customizable. You can just do everything from here. There is no need to go inside the blueprint even. So this water material, it is actually you can apply here the water instance, and I've already created the water material instance, and this is one of this. This material you can use however you want. It is included in the package. And that is it for the water. You can just replicate this water anyhow you want. Like I'll show you. I'll create a small I'll create one more water here. Maybe it is really easy. You just duplicate this and keep it over here. Set the column height to 100, and you just increase the number of columns here. Let's see, 23 is too much. 21, 22 maybe. Yeah. So now the water is filling, and if I play this now, you see it's playing. Everything is working fine. So this is it for the water part. And for the buoyancy part, this is the floatable object, and yes, this has its own blueprint. So you can just copy it. You don't need to copy it, you can just like alt and drag, and there you have two, and you can just use it. So every blueprint is reusable. You don't have to do anything. You can do it from editor itself. You just place this and you do it from the editor itself. So you might be wondering, what are these? These are 3D widgets for the array I have put inside. Okay, I'll go one by one. So this is the location. Okay, this is the normally location. Box extend. This is the box extend. You see this colliding box. I've put this for the simplicity sake, because this floatable object can be quite complex, and for the player to trace, like if he's standing on this, you don't need it to be perfect. Like when it is touching this log, you don't need that. So I put this collision extent in this, and instead of the log, this collision extent will deduct the overlapping. So that is it. You can set the extents. You see X and Y. You can just increase or decrease, whatever you want, something like that. And the object mask. This is the most important part in this. One of the most important part actually. So this will be the object mask. Remember to keep the object mask on the higher end, like 1000 or 1100, or if it is much larger, then more, because your character will weight about 100, and if you put this weight also 100, even though it might float, but I think it will not float actually, because the force applied to this object will depend on the mass. The logic is set up that way, that the force applied in this object will depend on this mass. And so if your character is like 100 and this is also 100, once your character touches this and you have some acceleration logic or something is going on, because the character is moving, this will go out of your universe, because this mass and this mass are equal. It's just game logic. And in Unreal, most of the time these forces go on the actually higher end. So you keep in mind that you apply larger forces so that it works. And once a character overlaps this, it has a function that will add the mass of the player to this, so that it maintains some stability, like because of the increase of mass. Actually it is only 100 kg, but anyway it is included, because if you were to add some like 1000 kg in this, so this object will sink or something like that. So this object's mass and this character's mass will be added together. That is how it is set up. Then about these pontoons, these are really easy to set up. If you have used the water system provided by Unreal, they also have these pontoon systems. So I just for the simplicity's sake I named that. Sorry for if the spellings are wrong, I'm not too good at that. So this is really easy to set up. Out of the box, at least one pontoon will be available, like it will be in the 000 position, and these are the relative position. Keep in mind that these are relative position. If you need to change anything, then these relative positions are converted into the world positions inside the logic, buoyancy logic. So but keep in mind these are relative positions, and these are really easy to set up. You just add number of arrays. Most of the time for like these objects, 3 will be enough, 1 in the center and 2 at the ends. So I've created 3 arrays, and you cannot see 3, but they are at this correct position. You just click on this 3D widget, just drag it out to the right, drag it out to the left. Okay, and if you now simulate the water, sorry, the PC is lagging. You see the object is submerged inside. This is because of the pontoon's position. If you place them here, the force will be applied at these points. So if you want the object to float above water like this, you just adjust the positions of the pontoon. So like this. Okay, so you adjusted the positions. Now you play. You see, now the object is floating above water. So this is normally this is it, but for your convenience, like this trace, and by the forces which are applied on these pontoons are traced with reference to this tracing object, water body, and I've created this water body. And for your new projects, this will not be available by default. You have to create it, and it's really easy to set up. It's nothing too much. Like you can just go into editor preferences, and you can search for, okay, it will be I think here somewhere, collision. Am I in the right menu? Okay, let's see. I think we are in the wrong menu. I think it's project settings. Let's see. Yeah, project settings. You go to the collision, you see this object channels, you create new object channel, you enter water body the same way I've entered down there. You can just check it out, water underscore body, and Walter is not Walter, is water body. Then you just default response to overlap, and you just accept. Alright, I've already created, so there is no need. You see water body, I've already created this. So for your convenience, you just need to add this water body, and the tracing object should be defaultly set to this. If it is not, you can just set it from here. The next thing is the sprite. The sprite will be the object you wanted to float. So this sprite you can just put here, and this is the most important. This is another most important part. This is the water body in which the sprite wants to float. So you can just click on this pick item, and whatever the water body is, like this water body you wanted to float, or this water body you wanted to float, so you can just click here and the water body will be picked. This is really important for the logic to work. If this water body is not selected, the object will directly sink. There is no other way. Alright, so I think that is basically it. It's really easy to set up and use in your games, and it is using the character. It does not need to apply any interface or anything, and for the floatable objects there is an interface, but it is already applied, so you don't need to do anything. The only thing you need to do is add this collision object named water body. That's it. Thank you guys for purchasing the product. Thanks.